Okay, this is part 2 of section 7.4. 7.4 is pretty long. A lot of it is repetitive, but I wanted to start with this one just because we're getting into confidence intervals. Identify the interval that includes 95% of the sample mean for a population with a mean of equal to 50 and a standard deviation equal to 14 using a sample size of 49. I'm going to show you the formula to get started is still the same formula. You need to calculate the standard error of the mean, and let me do that again. And once you calculate the standard error of the mean, you're going to find the z-value associated with that, okay? So if it's a 95% interval, you're going to say on either side of the mean, an interval is going to be that much plus and that much minus. So you're going to take 95%. 1 minus 0.95 is 0.05. Well, if you want it on both sides, 0.05 divided by 2 would be 2.5%. So 0.95 plus 0.025 would be 0.975. Okay, so you can use that value. You can find that value in your table. So you're kind of working backwards. So let me go over that again. You're taking 0.95%. You're going to take that 1 minus that is 0.05 and divide it by 2. So it's always going to be 2.5%. Now what I like to do is I just memorize the z-value associated with 0.975 or 0.95 technically. If you go to 0.95, 0.975 right here, the z-value associated with that is 1.9012345 So anytime you have a 95% confidence interval, and I want to say I put this in the formula sheet, the z-score associated with that is 1.96. Okay, so what you're going to do is you're going to take that z-score and you're going to take your standard error of your mean. Now, we know how to calculate that. Let me just do that real quick. Standard error of the mean, take your standard deviation of 14 divided by the square root of n, which is 49. The square root of 49 is 7, so 14 divided by 7 is 2. So your standard error of your mean is 2. So to get a confidence interval, or an interval here, as they say, a symmetrical interval, what you're going to do is, not sure why that's not, make this a little bit smaller. Okay, what we're going to do is calculate our standard error of mean, which is 2. We already got our z-score associated with a 95%. So what you're going to do is you're going to take your z-score. It's always your population mean plus whatever your z-score is times your standard error. So remember, z-score is 1.96, standard error is 2. So you're going to take your population mean, add it to it, and take your population mean and subtract it. So here's what we would do. 1.96 times 2, well, it's 3.92. So take your population mean. You're going to do 50 plus 3.92, okay? And you're going to do 50 minus 3.92. So what does this mean for us? We are 95% sure that the sample mean, okay, would be in between these two values is going to be, we're 95% sure, we're pretty confident that the mean should be in between 46.08 and 53.92. And I want to see if the examples are always good. You just got to know what all these little symbols mean to really understand the formula. Okay, let's just review. This is the sample mean. This is the population mean. This is the standard deviation. Okay, you did not have to calculate that. You could just use the table to find the z-score, since we know 95% is our probability or our confidence. We want to be 95% confident. So if you want an interval, you take your population mean and subtract out 1.96, which is your z-score times your standard error of your mean. Okay? Lots of little formulas, and you have to know when to use what. Okay? So the last thing it shows you is your interval would be in between these numbers. Your mean should be in between these numbers. We're 95%. There's a 95% probability that it will fall in between those. Hopefully I didn't confuse you. You just have to keep practicing the formula, and when I'm working these, I always write the formula down and then plug the numbers in, because the more you write it down, the more likely you are to remember this, what the symbols mean, not necessarily the whole formula. Let's look at question number 5, okay? What is the, I'm skipping down to find out what we're doing. What is the probability of obtaining a sample of 57 or less, a sample mean of 57 or less from a sample of 35? Okay, here's a little extra I'm going to throw in there. If you're getting a sample of 35 and your population is only 300, 35 divided by 300 is about 11%. So we're getting a pretty big sample here. Okay, if your sample is more than 5% of the population, you have this longer formula to use. Okay, this is called an adjusted formula. So you're still going to have the standard error of your mean. You still get that number, but then you've got to multiply it by this. Now, what does all this jump mean? It's just your population sample, population minus your sample. The number in your population minus your sample. The number in your population minus 1. Take the square root of it. Whatever you get, multiply it by your standard error. So they like to throw one more thing in there for you to remember. I'm not as concerned about this. Just remember, the big N is your population number. The little n is your sample number. So let's see how we end up getting our probability here. So when I calculated the standard error of your mean, you will take 28 divided by the square root of 35. And when you do that, I want to say you get 4.73. Okay? Now we have to take the 4.73 and multiply it by, that's our standard error. I like to have the formula here so I can point it out to you. Here it is. Okay, so basically, once you get your standard error of mean, let's go back to it. Remember, we had a little bit more calculation to do because our sample size was greater than 5% of our population. So when we do our big N minus our little n, 300 minus 35 over 300 minus 1, 265 over 299. If you divide that and take the square root, you get 0.9414, and then your standard error of mean was 4.733. So you have to take those numbers, multiply them together, and you get 4.46. So all of that just for the standard error. So that's a little bit different from what we've been having to do. Now, once you get that, you work it the same way, except we had a lot more to do to get this number here. So X bar, that is your what? That's your sample mean. Your sample mean is 57. Your population mean is 55. So 57 minus 55 is 2. And 2 divided by all that work it took to get the bottom number, 2 divided by 4.46 is 0.45. So if you go to your normal table, it's the second one, 0.45. Our number is 0.6736 because of rounding, and it would accept that number. Okay. And that is how you calculate the probability when you have a large sample size that's greater than 5%. Once again, how did I know that it was greater than 5%? Because 35 divided by 30 was, I think, about 11%.